mathematicians. Today we're going to learn a few more derivative rules focusing on trig, exponentials, and logarithmics. So let's start with some trig. Here are the derivative rules involving trig functions. The first one is sine of x equals cosine of x. Or if we have a constant here, sine of ax is equal to a times cosine ax. And the derivative of cosine is negative sine. Let's take a look at these two functions here. The first function we have is sine of x. And if we look, for example, at pi over 2, what's the derivative here? Well, if we draw our tangent line, we can see we have a horizontal tangent line. So our slope here is 0. If we look at pi over 2, the y value at pi over 2 of cosine of x is 0. So the slope of sine is equal to the y value of cosine. Let's take a look at pi. The derivative here, we draw our tangent line, it looks like it's about negative 1. And if we go to cosine of pi, our y value is negative 1. So we can see this is applying. The derivative of sine is cosine. Now, let's look at this cosine graph. We look at the derivative at 3 pi over 2. If we draw our tangent line, the slope looks like it's about 1. It's going up positive and looks like it's about 1. And if we look at sine of 3 pi over 2, the y value here is negative 1. So the relationship between derivative of cosine and sine is the same number, but change the sign. So it becomes negative. And you can kind of see that relationship carrying on from one side to the next. Tangent of ax, the derivative of tangent of ax, is a times secant squared of ax. Cotangent derivative of ax is negative a cosecant squared of ax. Derivative of secant is secant tangent. Derivative of cosecant is cosecant cotangent. Now, let's look at these a's. These a's represent a constant. So whenever you have a constant inside, you're just going to multiply it on the outside there. Let's do an example. If w of t equals 3 secant of 2t minus 6 cosine t, find w prime of t. So remember, when we have a constant in the front, we can just pull that out using our constant multiple rule. Now we're going to take the derivative of secant 2t. Well, we're going to be using this rule here. So we have a here is 2. So we're going to do times 2. The derivative of secant is secant of whatever we have on the inside times tangent of whatever we have on the inside. So that's the derivative of secant 2t. Let's take a look at the derivative of the next part now. The minus 6, we pull that out, and derivative of cosine is negative sine of whatever we have in here. Now I didn't have to worry about the a here because there's that invisible 1 next to the t. I want to note here, sometimes they put parentheses, like we have secant parentheses 2t, and sometimes they don't put parentheses, cosine of t. But either way, this t is the input into the cosine function. It's not multiplied by cosine. It's not cosine multiplied by t. It's cosine of t. It's the input. So now we can just simplify a bit. 2 times 3 is 6. Secant 2t tangent to t. Negative and negative is plus 6 sine of t. Now I want you to try this one on your own. If h of x equals 10 cotangent x plus sine of 3x, what is h prime of x? So let's do that out. So we have 10 cotangent x. We pull that 10 out. Derivative of cotangent is cosecant squared of x. Derivative of sine of 3x, we pull that 3 to the front, plus 3 times cosine of 3x. Voila, we're done. Now let's look at exponentials and logarithms. Mostly, they only ask about e to the x and ln of x. Here we have the graph of e to the x. And what's so cool about e to the x is that the derivative is the same. So what does that mean? So if we look here, what's the derivative here? Well, it looks like it's going up. The slope is about 1. That's also the y value. And if we look here at 1, our slope would be here is e. And what's really cool about this is that the y value and the slope of the tangent line are always the same for e to the x. For ln of x, the derivative is equal to 1 over x, which is the same thing as x to the negative 1. If we're taking the second derivative, you would want to convert that into your negative exponents, x to the negative 1. So the derivative of ln of x is x to the negative 1, or 1 over x. Let's do an example here. We have p of a equals 3e to the a minus 5 ln of a plus 1 over a. Now be careful here. You might be tempted to think, oh, ln of x derivative is 1 over x, so that's what this is going to be. However, here we need to rewrite our function to get rid of this 1 over a. So we can use our power rule there. So 3e to the a minus 5 ln of a plus a to the negative 1. Now we can take our derivative. P prime of a equals, remember that constant we can just pull out. E to the x or e to the a just stays the same. Let's do it in the next part. That negative 5 we can just pull out, constant multiple rule. The derivative of ln of a is 1 over a plus the derivative of a to the negative 1. We're going to bring down that negative sign. So we're going to have plus negative 1 a negative 1 minus 1. So if we simplify this out, we get p prime of a equals 3e to the a minus 5 over a minus a to the negative 2. And we can rewrite that as p prime of a equals 3e to the a minus 5 over a minus 1 over a squared. Now be careful with your notation. Notice when I rewrote it here, I did not put the prime. I just wrote p of a because I did not yet take the derivative. At this step, I took the derivative, so I write p prime of a. Now try the next one. If g of t equals 5 ln of t plus 3e to the t minus tan of 5t, what is g prime of t? So now let's check your work. We have 5 g prime of t equals 5, the derivative of ln of t is 1 over t plus 3 derivative of e to the t is just e to the t minus that constant inside of tan we pull out as well. And the derivative of tangent, if you look back, is secant squared. So secant squared of 5t. Hope you enjoyed. Please leave your questions for me at the end of the video.